Okay, welcome back. In this video, we are going to be talking about 4 of our exponent laws. Now, these 4 laws we're going to look at a to the power of m times a to the power of n equaling a to the power of m plus n. Another one we're going to look at is a to the power of m divided by a to the power of n equaling a to the power of m take n. Okay. The third one we're going to look at is powers of powers, so a to the power of m to the power of n, and remember there's always brackets in there, and that is a to the power of m times n. And finally, our last one is going to be the power of 0, so a to the power of 0 equaling 1. All right, let's jump right in then. So our first example, we're going to do for a to the power of m times a to the power of n equals a to the power of m plus n. Now here's how we're going to do this. A to the power of 4. Let's say a to the power of 4 times a to the power of 5. Well, a to the power of 4 expands to a times a times a times a. All right. Now, for our next one, a to the power of 5, we don't need to put the multiplication in the middle there because remember, in algebra, by default, it's always multiplication. So a to the power of 5 expands out to a times a times a times a times a. Well, how many do we have there? Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a to the power of 4 plus 5 equaling a to the power of 9 because we have 9 of them there. And that is our multiplication law for our first exponent law, or our first index law. So our next index law we're going to look at is our division law. So a to the power of m divided by a to the power of n equals a to the power of m take n. So in this one, we're going to go a to the power of 7 divided by a to the power of 3. Well, 7 expands out to a times a times a times a times a, all 7 times. All right, and we're going to divide that by a times a because that's how a to the power of 3 expands out. Well, now we can actually cancel some out. So if we've got one there and one there, they're the same, so we can cancel them out. And we're going to continue to do that until all of them on one side are cancelled out, or all of the denominators are cancelled out. And how many do we have left? We have 4 left. So this one here, a to the power of 7 is a to the power of 7 take 3, which is, how many do we have left here? A to the power of 4, and that's how we get that one. So our next one we're going to look at is our powers of powers, which is a to the power of 3 to the power of 4. Now, with this value here, with this exponent here, what this is saying is we need to multiply everything in here by itself 4 times. So what we're doing here is actually a to the power of 3 times a to the power of 3 times a to the power of 3 times a to the power of 3. That's how we expand everything that is in those brackets there. But we can still expand that further. So we can expand this as a times a times a, then a times a times a, then this one here, a times a times a, and finally our last one, a times a times a. Now for those of you counting along with us, you'll see over all of these, we actually have 12 of them. So a to the power of 3 to the power of 4 is the same as a to the power of 3 times 4, which equals a to the power of 12, which is exactly how many a's we have down here. Finally, our last exponent law we're going to look at is the power of 0, and that basically meaning that a to the power of 0 equals 1, and anything to the power of 0, 4 to the power of 0 equals 1, 16 to the power of 0 equals 1, even 128,000 to the power of 0 equals 1. So if you do have any questions, please, as always, write them down and we'll get to them in class because we want to do as much as we can in class. So by all means, please bring them along. All right, catch you later.